And I want to thank you all for being here today. This series of lectures, blogs that we've been doing once a month that MicroSeismic fell into was kind of a happenstance with a happy ending. We have a user forum every year where we bring in speakers from our community to talk about problems in the energy world. And this year we had to cancel at the very last moment because of the weather here in Houston, a snowstorm, if you can imagine. And we decided, since we had all of these wonderful speakers lined up, to try to run this over the year on the third Thursday of every month. And we would bring these speakers in and have kind of an interactive session. And it's worked out really well for us. Today, we have a very, very special treat in that we've got Bill Von Goten, who is probably the world expert on the shale plays. And he plays practices around the world, whether it's in the Far East or in West Texas or in Canada or in South America. He practices in all of those, helping operators to develop their shale plays, and has developed a tremendous insight to what makes these plays work. So Bill's going to talk to us, but first, before we get to Bill, I wanted to mention that this is an ongoing program. On the third Thursday in May, we will have Greg Matlock from Ernst & Young talking about the market for carbon capture. Really interesting with what's going on in the government these days. And I'm sure that Greg, who's a great speaker, is going to have some interesting things to tell us. Then the third Thursday in June, we've got Zach Liu talking to us about the Blue Flint CCS project as a case study. And it'll go on for the rest of the year. So if you're interested in registering for the talks, and I'll leave this up for a second, you can go to the QR code, and that'll take you immediately to the place where you can register for our future talks. And I hope that if you register, you're able to attend that day. We find that probably about half the people who register actually show up. However, we do record these, and they're on our website, so you can go back and visit them if you happen to miss. Or in fact, if you don't understand what's being said, you can go back and visit them again. And we will make sure that we put the author's email up there so that when you are really confused, you can write to them and see if you can get yourself sorted out. So now I'm going to turn it over to Bill, and I've already told you about Bill. Most of you out there probably know him, but I wonder if you know that his hobby is making organic moonshine. Now, I have to complain, Bill, that you didn't bring me any here today. It sounded really intriguing. And at some point in the future, I'm expecting you to share some of that organic moonshine with me.
I'm a little behind.
But for now, well, you're never in country. You're always in South America or somewhere. So I don't know how you have time to make it. But Bill's going to talk to us particularly about the Vaca Muerta. I heard Bill have an interview with Maynard Holt on his Close of Business Tuesdays program back in August of last year, where he taught me so much about the Vaca Muerta. And even though I've been traveling to Argentina for 10, 15 years, there was so much that he taught me and showed me that I didn't know about the Vaca Muerta. I really twisted his arm to see if he could come and share that with our community. So with that, I am going to, one other thing. Bill has said that he, being the brave man he is willing to take questions during the talk. So if you have a question, we're going to be monitoring. Either raise your hand or type into the chat box your question, and we will monitor these and pass them on, and Bill will maybe answer them as we go along, so you have a chance to understand or query everything that he's showing as we go. Now, if you raise your hand, that means you want to speak your question. We will unmute your mic, but then you have to unmute your mic as well. At the end of your question, we will mute you, and Bill will answer. So with that, Bill, over to you. Tell us about dead cows.
All right. Thanks for the humble introduction. An expert in Vaca Muerta. I don't know that there is such a thing, but I'll tell you what I know about it. And I'm sure my Argentine friends that are here will correct me with the questions that they will ask. So please ask some good questions. So we'll kind of go through an overview. I'm not going to be too detailed, but there is some interesting observations in the Vaca Muerta. It's a pretty unbelievable play. We'll go through it. And some of my hilarious staff added some comments in here. So we'll kind of go through the history of the Vaca Muerta, the potential and some current trends, and then, what's the upside, and then what's our operational challenges, which when we get into it, it's really going to be geomechanical, and you'll see why. But as Peter said, please ask questions as we go along. So a little bit of an overview. Where it's located, most of y'all know it's in the southern portion of Argentina and the Neuquén area. If you look at a geological column, it's lower Cretaceous, upper Jurassic, the Vaca Muerta Formation. The Quintuco is on top. Prodigio, Catrial is in the bottom portion of it. Peter didn't introduce me, but I'm a reservoir engineer, so the geologist, hopefully I did a good job of describing the geological aspects of it. And a little bit of how does it compare? Everyone always wants to put everything as a comparison to a U.S. play. I'll say that there is no comparison to a U.S. play, but most people compare it to the Eagle Ford. But just putting some typical logs, the first two are Vaca Muerta gas, Vaca Muerta oil. All these are on the same scale depth-wise, and don't get caught up in looking at scales, but the depth are the same. The red colors are hydrocarbon filled porosity. So you can see the gas, the Vaca Muerta gas. I put down at the bottom BCF per section, or million cubic feet. So you can see the Vaca Muerta is a half a B to 1.5 TCF per section, anywhere from 100 to 200 million barrels per section. Versus if you look at Wolfcamp, 100 to 150 million barrels per section, Sprayberry, 10 to 65, Eagleford, 20 to 40 million barrels per section, and so on for the gas. And so just some averages at the top, and we'll go through it in more detail looking at pressure gradient, but there's really no comparison as an analog to the Vaca Muerta. Mineralogy is a little bit different, so everything is different. At one point, the Aubrey McClendon used to compare the Vaca Muerta as the Wolfcamp sitting on top of the Eagleford. That was his comparison to what the Vaca Muerta was, and I think that's probably the best comparison. But the resource in place is probably bar none anything in the world as far as a resource in place. Who are the players in the Vaca Muerta? Just looking at it, kind of color code them. YPF is obviously the largest player, the blue acreage position. We'll kind of go through where these sit in the basin. Vista has Baja de Palo. They also have Aguada Federal, Banduria, Pan American has Banduria Centro, has some good blocks. We also have Tech Patrol has blocks. Shell has their blocks over in the oil region. Pampa has blocks in the gas region and the oil region. Plus Patrol, you probably saw in the news, Plus Patrol bought the Exxon blocks. Total has a lot of blocks, primarily in the gas region. Chevron, and then also Phoenix in the oil region. So you can look at the size of the blocks. They're large blocks, large acreage positions. And, the other thing you'll notice is not a lot of players, right? If you were to look at this in the Eagleford or in the Wolfcamp, anywhere like that, right, you would see hundreds of operators. Here, it's a list of 6 to 8 operators that are in the basin. So it's a limited group of operators, but large acreage positions. So what makes the Vaca Muerta so special besides the pressure, besides where it's located? The one thing that you're going to see when we go through it is the thickness. And I'm not going to get into a lot of detail, but what makes it so special is because of the basin, we have a lot of thickness. And then the thickness comes from these cliniforms, where because of the basin, we have these depositional facies, and we have basically the sediment is sloped off into the basin. And and it forms these thickness. And so as the basin is formed, these depositional surfaces builds outward into the basin. And so you can see it gets thicker and thicker. And I'm going to show you a cross section. The cross section will show you some logs here in a minute. So you can see as I go to the eastern side, it would be thinner, or the western side, eastern side. And if I go to the western side, it's going to get thicker, right? And so it changes. The Vaca Muerta will change with these claniforms. And you can, the good thing about it is you can see it on the seismic, right? You look at the seismic, you can actually see these claniforms. And if you look at the gray area at the bottom, that's the Vaca Muerta, right? And so just what I'm talking about, if you look at the eastern side, you would see, okay, it's thin. But if you look at the eastern side, Cerro Arena, this would be a gas area. You know, this is 600 meters of gas pay over here, extremely thick versus Antholomas, Baja de Palo. It's anywhere you would say, well, this is really thin. It's really not thin. This is still 150 meters thick over here. It does thin out over here, but even over here, it's 40, 50 meters thick. So this would be like Eagle Ford equivalent, still really, really good. But then it gets thick as you go over to the east, to the west. So the whole basin changes, right? It's not like we're used to in North America where we have kind of a constant 30 meters thick Eagle Ford across the basin. This thing changes in thickness. And so you're going to see some of the other maps that we have is not only do we have a reservoir that changes, we have a thickness that changes, we have facies that change. There's a lot that goes on here that changes. So you can go any part of the basin and have kind of a different play, different reservoir within the Vaca Muerta. And so the other thing we can see is looking at these facies on seismic, looking at the acoustic impedance. So a lot of this on seismic, you can see these facies. You can see the blue acoustic impedance is more of the organic rich. And so you can see our cocina, which is the very lower portion. And I'll show you here in a minute on the log. You can see the cocina shows up as the blue facies, and you can map this across the basin. Then as you get to more of the yellows is more of a carbonate facies. And so you can see how these claniforms kind of come in where you have them organics.
We have a question.
Uh-oh.
Corey, you can ask the question.
Thanks very much for passing the mic, and thanks for the presentation here, Bill. It's great so far. Is the Vaca Muerta the source and reservoir, or is it just the reservoir?
No, it's the Vaca Muerta is the source. Vaca Muerta is the source and the reservoir. It's self-sourcing.
Gotcha. Thank you.
Thanks, Corey.
So the great thing about it is the Vaca Muerta, there's a lot of geologists, really good geologists in the country that have done a lot of the mapping, so we can see everything with seismic. We can see the organic rich areas, we can see the carbonate rich areas. So to me, I see a lot of the Eagle Ford, not mineralogy wise, but I see a lot of the Eagle Ford and the Austin Chalk. I see the cocina is more like the Eagle Ford, more organic rich. And then a lot of the upper portions of the Vaca Muerta, which is more carbonate, is to me a lot like the Austin Chalk, but they're completely different. But to me, they have a lot of the same characters. Different permeability, different porosities, different mineralogy, but they're not an analog, but to me, they kind of have the same character to them. So looking at the depth, and you look at the well spots, you can see where all the wells are drilled. And there's a reason for where all the wells have been drilled. It's because, there was existing fields, right? The Vaca Muerta in the New Kent area, this is existing fields, right? Añelo, we were talking about the little town of Añelo. There was existing gas plants. There's been existing gas fields, oil fields in this area for a long time. And so all the existing wells are in the oil region. Most of the time, there are gas wells, Fortín de Piedra, down in the gas area. But most of the wells have been in the oil region where they're near existing infrastructure. And the depth of most of the production right now is between 2,800 and 3,000 meters. Now we're starting to develop the northern region. It's in the oil area though, but still about the same depth, maybe a little bit deeper. 3,200 meters. But the whole play is productive. But the reason the wells are down here is just where the infrastructure is. And this is a large area, right? So it's not like, it takes 6 hours to drive from the north to the south. So it's not like it's just a small drive to go. It's a big area. But look at the thickness, and this goes back to why did I show you the cliniforms? Why is an engineer showing you geology? Because this explains why the thickness changes. Again, you look at where most of the production is over here, which is what I told you, 100 to 200 meters thick. But look at this, it goes all the way to 1,000 meters thick. But again, over here on the western side, this 600 meters thick. There's a reason for that. That's those cliniform buildup. It was the Vaca Muerta gets thicker and thicker because of those cliniforms. This is the reason the thickness changes. This is what we're not used to in North America plays, like the Eagle Ford would be 30 meters, maybe 40 meters thick, all the way across the basin. This changes, right? The Cocina might be constant, but the rest of the buildup of the Vaca Muerta is going to change, right? So you would have blocks up to the north that may be 250 meters thick, and you may have a block way out to the east that might only be 60 meters thick. So big variations, and that's going to change your landing zones, right? You might have a block that has 2 landing targets, and you might have a block that has 4 landing targets. And then, some of these gas blocks over to the west, we don't know how many landing targets they're going to have because we haven't gotten to those yet because of the gas supply, the gas demand. So big changes in thickness. You look at our fluid phases. Now this is like the Eagle Ford, right? We have black oil, we have volatile oil, we have gas condensate, and we have dry gas. We have all fluid phases. And so that is like the Eagle Ford, right? We go through every phase. So there is just it's a good thing in that, based on what our product prices, and you see a lot of companies have blocks in both, right? A block in gas and they have a block in oil. When you kind of went through the blocks by company, you'll see a lot of them had blocks in both. And so when we get our gas demand up with LNG, then you can kind of switch fuels, right? Depending on what product prices are, you can kind of move around to whatever makes the most sense, economic wise. And so this is where the well activity has been. This is the current well spots. And this is interesting, you look at it and this is the surface locations of the producing wells. And something I didn't talk about on here is data. There's the data out here there's not a lot of public data. The public data is production data, surface location, latitude and longitude, not directional surveys. You'll get pounds of sand that was pumped, fluid that was pumped, and you'll get the TD of the well and lateral length, and that's about it. And so a lot of these circles might be 4 wells on a pad with the same circle on top of each other. So you don't really know where the laterals are. And so the data is not really available for detailed analysis of the wells. And so we have the luxury of working for a lot of companies and that can kind of sort this out. But still, you kind of get the what's going on is a lot of the production is in the oil region, right? In the oil phase, and a lot of it's down here where the infrastructure is. But now you're starting to see a lot of the production is going to be more in the northern, a lot of it's moving to the northern area. This is where the Exxon Bajada Choique block was up here, where some real prolific wells, and you're starting to see development up in the northern side of it. And then the gas, Guadalpachana has been down here, and Fortín de Piedra, where the gas is down still, where you have infrastructure in the southern end of it. So what's going on with production and why? If you look at the historical production, March 25, we're about 466,000 barrels a day and about 66.7 cubic meters per day, or 2.3 BCF a day. And if you look at the gas production, you can see it's seasonal because all the gas production is for internal demand, right? There's no exporting. And I saw that that Tech Patrol was exporting some through Bolivia into Brazil, but that's recent. But most of the gas production is for internal demand. And so it's seasonal. You curtail wells during the summer, which you got to remember their summer is our winter. And so this is opposite of what we used to see. But still, oil production is kind of on a steady increase. But there's approximately 2,000 wells producing. And you kind of got to think of that. You look at the scale at the bottom, and really it started in 2013 when we really started drilling successful wells. And we're just now at 466,000 barrels a day. And so, think about that and go back and look at the Eagle Ford. We started the Eagle Ford about the same time period because I remember that. And y'all look at the Eagle Ford graph, and what was it, in 4 years? We put 225 rigs in the Eagle Ford, and we got it to 1 million barrels a day in 4 years. And so we only have about 33 rigs. There's probably some more. We're bringing more rigs in, but it's been a slow, methodical, because of the 33 rigs. We're just not adding a lot of production per year here. And so it started in 2010 with vertical wells, and we drilled some early horizontal wells that were not successful. And then it's kicked off really in 2013, and it's just been a slow increase. And so I think that's going to change with what's going on in Argentina now, and hopefully with the activity that we're seeing, hopefully we'll see that as a change. And a lot of people ask, what's going to be the current production? Where is it going to? And it's not a reservoir problem. It'll go to whatever number of rigs you put on it. That's what the production is going to be. What's product prices and how many rigs you're going to put on it? That's what the production. But the reservoir is not a limit to what the production could be. So I was thinking about what kind of plot could we put together that would show what's the productivity of the wells. And so we looked at, again, this is public data, and so it's monthly. The public data is monthly. It's good data, and these are the horizontal wells. And we kind of said, what's an average horizontal well? And this is looking at the entire basin, right? And so the entire basin is 6 to 7 million acres. So it's a big area. It's averaging wells all over the basin. And so an average well is about 1,500 barrels a day. So that's what its average is for 30 days, right? And so obviously it comes on at a higher rate, but its average is 1,500 barrels a day. And so they are prolific wells. And so the other thing you notice is, look at the well count. These are oil wells. We're adding about 200 wells a year. Now in 24, you can see it's picked up. Went from 211 to 254. But still, we're adding 200, 250 wells a year is all we're adding. And so in order to get to, 1 million barrels a day, we're going to have to add more than 250 wells a year, right? So we're going to need more rigs in order to do that. So still, they're prolific producers. So what's our current trends? So I kind of went through, I've been asked a lot, what inning are we in? And I guess I probably misspoke on this because I've been working down here since 2012.
So we had a question.
We had a question.
You mentioned how the early wells didn't produce, and some unnamed attendee has chatted to us and asked, why weren't the horizontal wells successful? Were the fracs not working? These are.
Can I answer that when I get to my? I got a slide on that. Because can we hold that off? Because I got a slide.
You're in control. So you answer.
I'm going to answer that question because I have a slide on that. So please hold off. I'm going to answer that question. It's going to be interesting. So I've been asked, like, what inning are we in the Vaca Muerta? And I guess since I've been working down here since 2012, I kind of probably misspoke and said, we're 25% developed. And I finally sat down and put some numbers to it. In the area of the Vaca Muerta, if you kind of put the area, and this is my interpretation of productive limits, and it's probably going to move because it's constantly moving, and that the Vaca Muerta, that's a whole nother topic. It defies reservoir engineering. And if any of my Vista folks are on here, they know what I'm talking about, and that this reservoir produces low gravity crude, and I don't understand it. It produces low gravity crude through Nano Darcy Reservoir with low GORs, and it defies Darcy's law, but it does. And so we keep moving this line out. And so right now it's between 6 and 7 million acres. And so if you take 6 to 7 million acres and you take 200 meters of pay, there's a minimum of 2 landing zones, but really there's up to 4 landing zones. And right now we're drilling 2,800 meter laterals, but if you assume 3,000 meter laterals, 300 meter spacing, each well will drain about 220 acres. And so I made an assumption of the whole basin would be 60% developed. And that was based on some areas that might not be developed because of geomechanical reasons. There's a lake. And then I kind of back checked it by looking at the Eagle Ford. The Eagle Ford's 6.5 million acres. And it's basically kind of one bench, the lower Eagle Ford. And if you take the Eagle Ford, 6.5 million acres, lo and behold, there's about 29,000 wells drilled, and it kind of ties into the 33,000 that I came up with for this. And so it kind of works that the 60% number is a pretty good number. And so if you take the Vaca Muerta 60% efficiency and you take between 6 and 7 million acres, you get 33 to 38,000 wells that could be drilled in one bench. Well, if you drill 2 benches, which we are definitely drilling, the Cocina and the Organico, you would get, right, 66 or 76,000 wells. And so we've only drilled 2,000 wells so far that are producing, so it's only 3% developed. But, you know, this whole area over in here is 3 to 4 bench development. And so really the whole thing is, I don't know, call it 2 to 3% developed. So we are just starting, really, if you think about it, the development of the Vaca Muerta. So I always said we're 25% developed, but we're not. We're less than 5% developed. So still a long ways to go. And so this is kind of what I'm talking about, the benches. So we have the Cocina as the bottom. We have the Organico. And these are not, the geologists will kill me, these are not geological picks. These are landing zones, geomechanical landing zones. So the Cocina, the Organico, we call it the carbonate, the lower carbonate, we call it the middle carbonate, different geomechanical units, if we call them landing zones. And so we've landed wells in the Cocina, we've landed wells in the lower Organico, we've landed wells in the lower carbonate, we've landed wells in the middle carbonate. So we've already landed 4 benches that have been commercial in the play. And now the key is co-developing it. Can we land all 4 benches and co-develop the thing? Right now we've landed 3 benches co-developed in some areas. Now we're trying to see if we can land 4 benches co-developed. So just some generic trends. Lateral lengths, these are just, I won't spend a lot of time on it. But I think what I'm trying to show here is that, you know, we're not behind North American type trends. Our lateral lengths are on par, 2,800 meters laterals. We can go longer. This has all been kind of designed for efficiencies and drilling rigs and frac sets, keeping them in sync. So we're not drilling wells and then frac sets are waiting on drilling rigs. And so lateral length and frac sets go together. So we've kind of optimized that with lateral lengths. Yes.
Corey has another question.
Okay,
Corey, you can unmute.
Thank you very much. Can you please elaborate on what you mean by a geomechanical landing zone? I think I know what you mean, but just wanted to hear from you. Thank you.
Yeah, it's where we think we have prop connected fracs. Now our fracs go up. There's no, not in, maybe not in a specific area, but in the Vaca Muerta, there's not generally frac barriers per se. And so there's not, but what we do have is we have ash beds that I'll go through here in a minute. And so we do have pinch points. And so what we see are more geomechanical units in the way that where we have flow units, right? Where we have hydraulic fracture flow units. And so we call them landing zones where we think that's where the well is primarily draining from. But it changes, right? And so it's just a nomenclature that we use, we as in Bill personally use. So the industry, each company has their own different nomenclature for that, Corey. So don't take mine as what the industry uses. But I use them because that's where I think a lot of the companies I work for, we think that's where the fracs produce from. But not necessarily, it's not written in stone. We test that with MicroSeismic, we test it with tracers, with vertical wells, with dipole sonics before and after frac. So we do a lot of calibration on that. All right, so lateral lengths, proppant loading, you know, we're at 2,400, 2,500 pounds per foot proppant loading. Fluid loading, you know, 45 barrels per foot. You know, if you look at what we do in Eagle Ford and Permian, you'll see the same type numbers, right? So no different. Same type pumps that we see in North America, same rates, 80 to 100 barrels a minute. Everything is the same, no different. Stage length, 60. We've done the same thing. We've tried everything, different cluster spacing, cluster design, stage lengths, 10 clusters per stage, 5 clusters per stage. And so we've gone through a lot of the different testing to see what's the optimum, just like we've done in North America. So we put this together to see, you know, how does the Vaca Muerta, what's a quick graph? How does it shake out versus other plays in North America? And the spider plot, you know, if you kind of look at it versus the other plays, obviously, you know, the reservoir pressure is a blessing and a curse, right? If y'all know geomechanics, our pore pressure is 0.9 psi per foot. You know, it's one of the highest. It is the highest pore pressure resource play. You know, some of the Middle East plays are 0.9 psi per foot, but it's one of the highest plays in the world. Thickness, 225 meters. You know, we don't have anything. I guess you could say the Permian, if you took Sprayberry and Wolfcamp, maybe you could say that it's on par with that. But you can't compare with the porosity, you know, 10% porosity. And we'll show you the log in a minute. We have 225 meters of 10% porosity. We have low water saturations, so high hydrocarbon saturations. We have high TOC. We have some intervals, you know, that are 10% TOC. And we have low clay content. And so if you look at it, it's kind of the best of the best. And as far as the plays we look at, North America and really throughout the world, as far as the resource in place and as far as reservoir quality. And so looking at a couple of logs, one in the north and one in the south, and I drew some lines on here. The thing to look at is the green, which is hydrocarbon fill porosity. And this is our petrophysics. It starts on the right-hand side is 0 and the left-hand side is 20%. So I drew this red line, which is the middle would be 10%. And so you can look at this log, it's 200 meters of basically 10% hydrocarbon fill porosity. Show me a play like that in the world that has that kind of a resource. And then you go to the east, and it's 150 meters of, 10% at the bottom and 8% at the top. And so, that's been the, it's a good problem to have, which is, we were talking about this yesterday, which is, you start this play at 200 meters, where do you land a well, right? Do you land at the bottom? Do you land at the middle? Do you land at the top? And so this is where geomechanics comes in, is where do you land a well? And so I'm going to answer that question that someone asked here in a minute. And it's going to be geomechanics. But right now we've landed at the Cocina, we've landed at the Organico, we've landed at what we call the lower carbonate, and we've landed at the middle carbonate. And so I think there's even more landing zones that we'll find when we start to develop this. So how does it compare? Just a quick comparison. Put it versus the Eagle Ford. It's just it's not an analog. I mean, even mineralogy, right? The Eagle Ford, is more calcareous. The Vaca Muerta is more. It's got more siliceous content throughout the whole interval. And then what the Eagle Ford has, Eagle Ford is one landing zone. The Vaca Muerta is 2 to 4. Eagle Ford, maybe if you go to the Carnes Trough, you have maybe comparable pressure. The Vaca Muerta is just overpressured throughout the entire basin. It's 0.88 to 0.92 throughout the entire basin. So not really comparable. And then if you go to the Permian has the thickness that the Vaca Muerta has, but it just doesn't have the hydrocarbon fill porosity, right? It's 4% versus 8 to 10. And then the Permian doesn't have the pressure, right? It's 0.5 to maybe 0.6 in some of the best areas where, we're 0.88 to 0.92. And the engineers understand Darcy's law, and pressure is in the numerator, right? And so pressure and permeability are in the numerator and thickness is in the numerator. And so we're going to have higher flow rates as long as we have stimulated rock volume because of the pressure. And so what's the catch? If this is so good, and it is good, well, what's the catch? So we've got, when people come in and they say, why do I want to be here? And you do want to be here, and I teach my class at A&M, and I tell everyone there's 3 things that make an unconventional work: storage capacity, flow capacity, and geomechanics. You have to be able to frack it and keep it open. And a lot of people forget about the last one. And that's going to answer the question that someone asked. And so if you look at the Vaca Muerta, anybody can look at a log and come to the conclusion we have storage capacity, right? We have porosity and we have thickness. Flow capacity, anybody can look at the pressure and go, we are overpressured. And then do we have permeability? We've done extensive testing on permeability. We have permeability. We have good permeability. It's comparable to the Eagle Ford, if not better. I'd say it's comparable to Eagle Ford. But what about geomechanics? And I said earlier, overpressure is a blessing and a curse, right? Our pore pressure is 0.9, but overburden is 1.05, right? And so as pore pressure merges with overburden, it becomes a curse, right? And so at some point, you start to create horizontal fracts as your overburden, as your pore pressure. So if I start out with a pore pressure of 0.9, it takes greater than that to create a hydraulic fracture, right? And so as I start to initiate fracts, I'm approaching overburden immediately. And so this is the key to the Vaca Muerta, is understanding this and understanding the stress environment that we're in and understanding the rock fabric. And how does all this fit together is the Vaca Muerta. So this is the key to the Vaca Muerta. And so you've got it's interesting. There was someone in my office yesterday and I said, you know, you go to the Vaca Muerta and you look at every company in the Vaca Muerta, and every company has 2 people plus on staff that are geomechanics experts. And I said, go to any company in North America and find a geomechanics expert on staff. There's none. And so that's what you've got to do in the Vaca Muerta. And so, you know, the key is understanding that. And then, you know, what's our stress regime in the Vaca Muerta? Are we strike slip or are we thrust fault? Again, you know, S sub V, you know, the overburden, is it the minimum? Like I say, it's borderline, right? Depending on where you are. And what I'm going to show you is the fabric of the rock. We're borderline. When we start to hydraulically frac these wells, we're borderline where the minimum is the overburden. And why is that? A, it's the stress environment, and then B, the Vaca Muerta has fabric, right? This is a picture of the outcrop, and you can imagine what it looks like, you know, on the cores. It is layer after layer after layer. It's ash bed, it's beefs. These are beefs, calcite veins, and then ash bed, and then organics over and over and over again. And so that compounds. How does a fracture propagate through that rock? And so that's what, and you know, if it was just a black organic shale, it would be much easier. But then adding this fabric to it, it doesn't take much. All of a sudden, we have this issue of we exceed overburden and we create this horizontal component. And then we have volcanic activity, you know, on the edge of the basin, large volcanic activity, and then we've got influx of ash beds. And the ash beds themselves, some create pinch points for the hydraulic fracture, and then some create interfaces, right? Where we have sharp interfaces. So if a frac is going through it, you know, how does the frac, it's another layer, right? It's more fabric. Besides the fibrous veins, it's more layers as the frac has to go through it. So all this can assist in causing the horizontal component to the hydraulic fractures. And so this is an example I actually forgot about. I found in the outcrops of the Vaca Muerta, and I'll play it forward. I guess it'll go forward. But if you look at it, what you'll see is there's a fracture, and this is an ash bed. And what you'll see is this natural fracture split into 3, right? And this is what I'm talking about. This is not a hydraulic fracture, but this is what my mental picture of what's going on because of this fabric is. We're creating complex fractures, which everybody would say, that's great, right? That's what we want. We're creating stimulated rock volume. No, that's not what I want, because wherever I create this complex fracture, this is a pinch point, and this is going to close off. And so if my wellbore was down here, I have conductivity, but this is an ash bed that's going to pinch off. And so I'm losing all of this conductivity above this. And so this is not what I want. And so I think this is the role that this fabric plays, and this is the role that this overburden plays in creating these horizontal components to the fractures. And so here I'm going to answer the question. So this was an outcrop field trip that we did. And so I don't expect you to answer it, but this picture and this view was one of the issues. It was one of the instrumental trips that changed the Vaca Muerta. And so what I said is, what do you see in this picture besides a person standing there? And so I'm going to answer it, but this picture changed the Vaca Muerta. And if some of y'all are on here could probably remember this, but what I see, and I remember this was our original landing zone. And if y'all remember in 2012 and 2013, 2012, when we drilled horizontal wells, What was the theory in 2012? You drill brittle rock, right? So you drill the carbonate-rich rock. That worked when your pore pressure was 0.6 and 0.5 psi per foot. But when you drill carbonate-rich rock that's layered and your pore pressure is 0.9 psi per foot, what do you think happened? You had horizontal fractures, right? And so why did the early wells not work? It's because we created horizontal fractures and we didn't create stimulated rock volume. And so our height, was extremely small. And so the performance of the wells were horrible. So you think about that log that I showed you, you had 200 meters of pay. How can you possibly drill an uneconomic well in 200 meters of pay? We did, because we didn't connect to 200 meters of pay. We connected to 5 meters of pay. And so when we went to the outcrop, we looked at this and all of a sudden it was an aha moment. It was like, wait a minute, we're drilling down here. I want to drill up here. I don't see any beds. I don't see anything. I see a constant slope of shale. And if I land there, my fracks are going to go all the way till they hit those beds. They're going to go all the way to the top. That is a quiet area. And that's where I want to land the wells. And so what did we do? We went back and we proposed a well to land there. And actually what we proposed, this is public data, we proposed a well, the compromise, we proposed a well, land half of the well down here and half of the well up here. And that's what we did. And Peter shot MicroSeismic on it. And the MicroSeismic in the lower portion was quiet, and the MicroSeismic in the top portion showed that we create vertical fracks, and that well changed the whole thing. That well was the largest producing well at the time and changed everything. So what we showed was we were creating horizontal fracks where the carbonate beds were, and now we went to the quiet area, which showed that geomechanics worked, and we started creating these vertical fracks. So that changed everything.
So Darren has asked whether you can put specific values on these geomechanical properties to help you make that decision.
Yes. So now we've done, I wasn't going to talk about that, but we've done a lot of testing on those interfaces and put values on it of friction and cohesion and leak off. And so now we have that built into our frac models on how are those properties going to change. And that's something that we've been working on. It is not static. It is dynamic. The first stage that you pump, it's a set of properties. The fifth stage that you pump, they're changing. So it's complicated. Unfortunately, it's complicated. Nothing is easy. But the prize is worth it.
Yeah, no kidding.
And so that's the prize, this is the 24 wells, how does it compare? And this is the prize. And I just looked at what's the average production of the wells drilled in 2024 versus the other plays. And you can see for 12 months, we cumed 300,000 barrels for a 3,000 meter lateral. There is not a play in North America that has wells like that. That's an average well. We cumed 300,000 barrels in 12 months versus, the Delaware's 200,000 barrels, or Eagle Ford's are 150. So we're double the Eagle Ford wells productivity wise. And on the gas is not really a comparison because the gas is curtailed, right? And so we have to curtail the wells on the gas. But the gas, if you were to look at the productivity, Q divided by delta P, the gas is more prolific than anything we have in North America, but we're curtailed. And so the prize is worth it, but you have to focus on the geomechanics side of it. I think that was it. Well, maybe I had one more. Okay, so that's the closing comments. World-class resource. We have the technology. I hate it that it was a slow development, but I think we learned a lot because the development was slow. And so we didn't follow learn from the drill bit. And so we took a systematic approach. We did a lot of science, a lot of engineering and science to get to this point because it was geomechanically intensive. If we followed by drilling wells and just doing it the statistical way, we would have, this would be bad, right? Because this is geomechanics. This is not learning by pounds of sand and landing zone. This is geomechanics. And so it took geoscience and engineering to understand it. So now we're trying to understand, how do we maximize co-development? How do we maximize infill development? Because like I said, the next one, the geomechanics are dynamic, right? So if I drill a pad of wells, the geomechanics are changing and it's affecting the next pad of wells. And so we're having to build that. That's where we need you, Peter, to help us with this. We're having to build that next pad, and how are the geomechanics changing with the next pad? And it's exciting because it's challenging, but like I showed you on the slide before, the prize is unbelievable, right? 300,000 barrel cum in 12 months. It's an unbelievable resource.
And you can get that resource out, can you?
Absolutely.
Perfect. Perfect. And you can get money out now.
Yes, you can get money out.
So now Argentina is a real place to do business.
Yes. Yes.
Well, Bill, I can't thank you enough. And you've shown us a lot more here than what I saw with Maynard back in August. And it's just been a fabulous masterclass in how to approach a play in the world. I don't know whether we've just got a couple of minutes.
Yeah, sorry, I went too long.
No, you went, that was perfect. That was perfect. I'd rather hear you talk, but does anybody out there have a question? Corey has a question again. Yes, Corey. Would
Sorry
you
to
like to?
monopolize the question and answer. Are operators interested in deploying technology? Is it conservative? Are people open-minded? Is it an aggressive market when it comes to deploying technologies to answer these geomechanical questions?
Yes, we have to. You know, we can't spend, these wells are expensive. And so every well has to be economical. We can't afford to do a statistical approach, you know, and drill 10 wells and hope for a good average. And so if we can deploy technology that makes step changes, we have to do that.
Perfect. So thanks, Corey. So Bill, one final statement, if you would. Just, I was going to ask you earlier, have you broken the code? Have the engineers broken the code yet in the Vaca Muerta? And I think you've said no.
No.
Geomechanics is a big problem and it's dynamic. What concrete steps are you taking to solve that problem, or how would you forecast you're going to attack this problem over the next 2 years?
I mean, we're making some inroads in that we're trying to understand. We're taking data that we didn't know to look at before, a lot of the hydraulic fracking data, stage by stage, and we're looking for, could we have seen that we were creating hydraulic fracks with that stage? We're taking that data. We're looking at the flowback data. We're now that we kind of know that we were creating a horizontal component, now we're taking all the thousands upon thousands of stage data and we're going back and seeing, could we have seen that? Where we didn't know to look for that before. And so there's a tremendous wealth of data, second by second pumping data, that we're going back to see, could we have learned from that? And so that's the next step that we're working on.
Sounds like a lot of work, but if none of you have, if any of you out there haven't been to Argentina, and I know Bill's almost living there nowadays, it's a wonderful, wonderful place to go. And it just seems to be, to me, to not be fair that they have such a huge resource and some of the best wine in the world. So lots of work to be done there. Sounds like a lot of fun. And I cannot thank you enough, Bill. This has been a fabulous presentation. I know that the 100 people who are on the line out there that have been watching this have really benefited from it. Tell your friends, you can see it on our website. come next month, May 22nd, to hear about the evolving market of CCS. And I hope that we can continue to produce talks for you once a month. I know this has been a high bar for us to meet in the future. We'll see you next month, folks. Thanks very much.